welcome back to another lecture. In this lecture, we will be studying the most weighted and most important chapter according to JEE Mains perspective, and some of the questions are always asked in JEE Advanced also. The chapter is geometrical optics. In other words, we can call it as ray optics. Okay. So let's start with this chapter, and this chapter is mostly like a formula based chapter. If you know like the formulas, if you remember, and if you just know how to apply it, I think that's more than sufficient to clear any question in JEE mains. Okay, let's get into the chapter. First of all, you need to know what is a ray. This single line will be called as a ray. This will be always in a straight line, okay? And a bunch of rays will be called as a beam. Okay. Moving further, law of reversibility. So what is a law of reversibility? Let's say you have a source, okay, and light is incident, fine, and after reflection it moves like this. Let's say there is a plane mirror here, okay. After reflection it moves like this, and it is collected by another source B, okay. So let's say from source B where this light exactly meets, I'm gonna emit another radiation or a light, okay. So the path will be like, it will be the exact same path where the light came from this side will be equal to exactly the same path this side. That's called law of reversibility. When you reverse the sources also, it will follow the same path. For example, light is moving like this. Let's say there are plane mirrors. If I reverse the path, it will be in the same direction but this side. That's exactly what does this mean. Moving further, first law of reflection. Okay, what does it mean? So this you would have studied lot of times. Let's say this is the incident ray and this is a reflected ray, and let's call this as angle of incidence and this is angle of reflection. Okay, let's take it as R, and this is normal. Understand, normal is always perpendicular to the surface, fine. So the angle of incidence will always be equal to the angle of reflection. It can be any surface. Angle of incidence will be always equal to the angle of reflection, fine. So this is the first law. Second law, incident ray, normal, reflected ray lies in the same plane. Okay, what do I mean by the same plane is like xy plane is the same plane, right? If it lies, it will be in the xy plane only, okay. It can't be like something like this. When you see from this direction, let's say when you see from this direction, it will be like a straight line, like everything, like this will be an incident ray, behind that white is a normal ray, and behind that green will be the reflected ray. Like it will be like a straight line. That's what I mean by the same plane, fine. Moving further, we need to study incidence. What is incidence? Simply, a source produce an incident light, right? So that is called incidence. Something producing the light is called incidence. When a light is produced, it's called incidence. So incidence is divided into two types. Like there isn't like a category for incidents, but we can divide like a special cases. Let's say this is special cases, normal incidents and grazing incidents. So what is normal incidence? Let's say this is a mirror. Okay, I'm gonna start a light at the normal itself. Okay, I'm gonna incident a light in the normal, so it retraces the same path. Okay, this will be called as normal incidence. So what is grazing incidence? Let's take a spherical here, and I'm going to graze the light here. I'm going to incident the light in such a way that it grazes the surface. Okay, in this case, angle of incidence is equal to angle of reflection because it's a law, and that will be equal to 0. In this case, I should take perpendicular, normal is perpendicular, and angle of incidence is equal to angle of reflection is equal to 90 degree. Okay, moving further, a lot of students make mistake in this. All the angle in reflection and refraction are measured from normal. What it does mean is, sometimes in questions they'll give this angle. You shouldn't like directly take this angle and calculate the value. No, all the angles, if they asked you to calculate the incident ray, it is measured from the normal only. Okay, you should take 90 minus theta in this case. Fine, this will be the correct method. Okay, next, this is important, and sometimes the question will be asked from this directly. So if this is an emergence, let's say call it as a unit vector, and this direction as a unit vector, and let's say this is n cap normal, and this is theta and this is theta. So this vector, this direction can be written as e cap minus 2 e cap dot n cap n cap. Fine. If you don't understand, let me give an question to make you understand this. A light ray incident along a vector I cap plus j cap minus k cap on a plane mirror in YZ plane. The unit vector along the reflected ray is, so they have given a vector. Okay, a light ray is incident along a vector, which means the angle of emergence, the vector of emergence is given, but we need to take e cap only. So j cap minus k cap divided by root 3. Fine. And what about normal? Since it's given YZ plane, normal will be in YZ plane, normal will be in plus I direction. okay, plus I direction, okay. So n cap is equal to plus I, fine. So we know the formula, r cap is equal to e cap minus 2 e cap dot n cap, right? So e cap is given as I plus j minus k cap divided by root 3 minus 2 1 by root 3, okay. E cap dot n cap is, we need to take only this, right? So 1 by root 3 I cap, fine. So this will be our final answer, okay. Moving further, angle of deviation. So we will see two types. In that, first type is by one plane mirror. First, let us understand what is angle of deviation. Let's say a light rays incident and it gets reflected, right? This is a plane mirror, okay. It gets reflected and we know this will be theta and this will be theta. But let's take off this plane mirror. If the plane mirror was not there, it will be going like this, right? It will continue to go like this. So the angle between this and this will be called as the angle of deviation, that will be denoted by delta. So it's easy, right? The angle of deviation formula, angle of deviation is equal to, the total angle will be 180 minus 2 theta, that's it. This will be the formula to use when one plane mirror is there. Let's go for type 2, where two plane mirrors are there. Let's say you incident an angle like this and it goes like this and it comes like this, right? This is the path, fine. So let's say, and this will be the deviation, fine. Now I can call this as alpha, and then this also will be by alpha by the first law, and if I call this as beta, this will be also beta. Let me make it clear, right? Two mirrors, I'm gonna put an incident ray here, it goes here and it goes here, and this we need to find angle of deviation, fine. This is the path, this is alpha, this is beta, okay. So we know that this is the normal, right? This is normal and this is also normal. So can I tell this angle is 90 minus beta? Can I call it like that? Similarly here, can I call this 90 minus alpha? Yes, right? So this will be theta, fine. So how to find this angle? How to find this angle? We know this as 180 minus 2 alpha, right? What I'm asking? I'm asking this deviation is 180 minus 2 alpha, right? So if you don't understand, the total angle is 180 and this is 2 alpha, then we can find this, right? This is the deviation of this, fine. Okay, this is deviation 1 and this will be deviation 2, right? Okay, so that will be 180 minus 2 beta. Okay, we know that in a triangle, if we add the exterior angles, it will be equal to the another exterior angle. Do you agree with me? So I'm going to add both. I get 360 minus 2 alpha plus beta. Fine, clear? Now we need to find the alpha plus beta. Let's see, in this triangle I'm going to add the angles. Theta plus 90 minus beta plus 90 minus alpha is equal to 180 degree. Okay, this will get cancelled. Okay, and I get theta is equal to alpha plus beta, and this will be converted as theta. And for two plane mirrors, the deviation will be equal to 360 minus 2 theta. This will be the formula. Fine. Moving further, when, let's say, an incident ray, right? We are gonna fix this source, and we are gonna rotate the plane mirror. Fix the point here. I'm gonna rotate the plane mirror by an angle theta. Initially it will be like that, but after rotation it will be like this, right? If incident ray is fixed and plane mirror is rotated by angle theta, then the reflected ray will rotate by angle 2 theta. Okay, incident ray fixed. If plane mirror theta, the reflected ray will rotate by 2 theta. Okay, clear? Now let's go for image formation by a plane mirror. Image formation by a plane mirror. Let's take a plane mirror. Okay, so this we will call it as a silvered side. Okay, and this is a plane mirror. This is where the reflections take place. And now I'm going to place an object in a distance d. How will the image will be formed? Let me put a ray, normal ray. Okay, so it will go and come back in the same direction as I said before. Second, I want to put a ray like this, incident ray like this. Put is not a very professional word in physics, I'm sorry. So it's like it will be going like this and it will be coming like this. Do you agree with this? And this will be alpha, this also will be alpha. That's not required for now, just for clarification. Okay, in case of plane mirror, only virtual images will be formed. So when we extend this ray, always we should extend the ray which is reflected. Okay, we shouldn't extend this is wrong. We should only extend the ray which is reflected and going. Fine, so this reflected is going like this, so I'm going to extend like this. Fine, here is where the image will be formed. Here object, so this will be in a distance d. Fine, okay, so how will be image formed is, so what is an image? So image is a point where reflected ray are meeting or tend to meet is called image. Fine. So understand the point. Okay, the image is a point where the rays meet or tend to meet is called an image. Real image is when it meets. Okay, virtual image is when it tend to meet. Fine. Let's see the properties of image. Okay, what is the properties of image? It is equidistant, which means if you keep a object in distance d, the image will be formed in distance d. Okay, it is equidistant, it is laterally inverted, and it is virtual image. As you can see, like, it's always these are not the real rays, right? The real rays gets diverged and goes like this, gets reflected and goes like this, but the image are tending to meet. When they tend to meet, it is a virtual image, so it will always form a virtual image, and it will be of same size. Fine. So if the object is height h, the image also will be height h. That's it. Fine. And a fact that a lot of students may think that let's say here there is an object is placed. Fine. So where will be the object image will be formed? Object's image will be formed. A lot of students will say here image. Okay, at the distance d, as you said, distance is equal, the image will be formed here. But that's an absolutely wrong statement, where the object will be formed here. Okay, perpendicular always. Okay, like, what do I mean by always is, let's say a case where the mirror is like this. Okay, object is here, and as you can see, there is no mirror here. Fine, this is a free space, mirror is only here, and object is here. Will the image will be formed? Yes or no? Of course yes, the image will be formed. It depends on the perspective, from where will you be able to see the image. For example, if you are seeing from here, the image you can't see it. For example, you see it from here, maybe you can see it. Let's see whether you can see it from here or not. So how will the rays will be? It will go like this and reflect like this. It will go like this and reflect like this, right? A bit, yeah, right? So as you can see, it is at the point where you can see the image. So if your eyes is here, you can definitely see the image which is formed virtually opposite, and this will be at a distance d, this will be at the distance d. Okay, now moving further, let me give a question. Let's say there is a mirror 45 degrees tilted. Okay, here there is an object, and this is 2 centimeter. What will be the coordinates of the image? Okay, so some people will say here, which is 2, 0, just because it's minus 2, 0. Some people will say like this, which is absolutely wrong. Just now I have teach that. So what I will do is, the first step is to extend this, and second step is to draw this axis, fine, and third step is to find this. So I will say it's going to be formed as minus 0 comma minus 2, fine. Okay, so another basic type of problems which comes in these mirror questions, maybe in GK questions they would ask, like attitude questions, aptitude questions, like in BitSat there is some problems, right? So in those type of questions they may ask this question, like clock problems, fine. Let's say a clock is like this. In mirror, what will the time be shown? This question is pretty direct, and you can say it directly. It will be seen like this, and you can calculate the time directly and say it. But don't you think it will be complicated when it shows time like this, right? In seconds there is a difference. So there is a shortcut for it. So what is the shortcut is, take this time, okay, and minus the given time. Let's say it's like this, and the time is 2:35:15. Just subtract it with this, and the time shown in the mirror will be the answer, 24:45, and that will be the answer, fine. Good. Moving further, let's take an interesting question. Like, lot of people would have studied this, but a lot of people don't know how it is proved. Like, if there is a boy standing in front of a mirror, how much length of the plane mirror he should have such that he can see his full body in the mirror, fine. That's the question. You know the answer, it's going to be h/2, but how? That's what we're going to see now. Let's say a boy is standing, okay. Let's say a mirror, a big enough height mirror is there in front of him, and he need to see by his eyes, right? So the diagram will be like this. That from the toe the rays will be like this. Do you agree? And head is here, right? So one, from eyes there will be a straight line passing, fine. Let's take this, fine. And another thing is, another ray will pass like this, right? If I'm not wrong, let's draw his head a big, okay, yeah, fine. So as I said, you need to extend in the reflected path. I'm going to extend it. Let's draw it like a natural, and I'm gonna okay, and here it is, the rays are coming from the head, right, and goes to the eye. So this will be the reflected path. So I'm going to extend like this, fine. Finally I'm going to join like this, fine. And let me name the points. Name this A, B, E, C, D, M, Z. Some general points, I don't know, like, let's keep something, Z, K. Oh, that's named already, fine. So these are the points which I want to take. So if you remember, there is something called similarity of triangles, okay. I need to measure this height, so let me call as X, let me call this as Y, and this is the exact length needed for the boy to see his whole image. Fine. So x plus y will be the answer, but we need to find. So can I tell that a b by c d will be equal to EB by BD, EB by ED, right? EB by ED. So EB by ED, right? Hope you understand. Fine. Now we have taken AB, which is X, as we have marked there. And what is CD? What is CD? Okay, let's have this CD itself. Okay, CD is equal to EB. What is EB here? And this is L, and this also will be L. Okay, L by 12, right? Do you agree? L and L will get cancelled, and X is equal to CD 1 by 2, and C will go on that side. It will get like this. Fine. Equation number 1. So similarly do it for this triangle BZ by DH is equal to EB by ED, right? So what is BZ? Y. What is DH? I don't need that. What is EB? L. This is 2L. Fine. Clear? So now same, I get 2y is equal to DH. Fine. Can you tell that CD DH will be the height of the boy itself? So can I tell CD plus DH is equal to H? Okay, I'm going to apply it here. Okay, CD plus DH is equal to H. So CD plus DH is equal to 2y plus 2x. Fine. I want to convert this as H. Okay. Now I'm going to take common y plus x and 2 common outside, and taking this on the other hand side, it will be h by 2, right? What is x plus y? The total length of the plane mirror needed. Fine. Got it? So h by 2 length is required for that boy to see his whole image. Okay, let me give another step up question. A boy. Okay, why not to taking a boy again and again? Let's take a girl. A girl is standing. Let me draw the diagram instead without wasting time. Let's say a girl. Boy or girl, the diagram is same. It's a stick man. Fine. She is standing between a wall and a mirror. Let's say this is a wall. Fine. Find the minimal length of the mirror required so that the girl can see the full image of the wall inside the mirror. She need to see the whole image of the wall inside this mirror. So what is the size of the mirror required? The minimum length required. So similarly, I can tell that the wall's height comes from here to here, right? So it comes here to here. Okay, do you agree with this? Of course you must. And let's say the distance is A and the distance is B. Fine. So here also the same distance will be there, which is A plus B, right? Because she needs to see the wall, not her. So A plus B will be the distance. Fine. So we need to extend the reflected ray, which is this one and this one, and draw a straight line always, and name the points A, B, C, D, F, G, H. Fine. Now A, B plus by C, D is equal to H, B by B, D. Do you agree? Fine. What is AB? Let's take this as X, this is Y. X. What is CD? We don't know. What is HB? What is HB? It's A. What is BD? What is BD? It's A plus B, right? Fine then. What do you need else? But if you carefully see, we have taken A plus B, which is simply the distance between the mirror and the wall, right? Image of the wall. But shouldn't we calculate add this distance also? Okay, so we put 2 in front of here. Fine. 2A plus B will be the distance between the girl and the wall. Fine. Now similarly, like that, taking for this triangle also, I'll get something like Y by DF is equal to HB by HD. Fine. So similarly, 2A plus B. What is HB? HB is A, right? Fine. Now just get the answer. It's gonna be X. 2A plus B by A is equal to CD. Y 2A plus B by A is equal to DF. Fine. CD plus DF is the length of the wall. Fine. So just add both. 2A plus B by A plus X 2A plus B by A is equal to H. Fine. Y 2A plus B, I'm gonna take 2A plus B as common, and X plus Y by A will be equal to the H. So yeah, H plus Y is the answer which is required, right? So HA by 2A plus B will be X plus Y, which is the length of the wall required, and this will be the final answer. Fine. So moving further, so we need to learn something, field of view. So what is a field of view? If you remember something before, we have seen a problem like this, right? There's a ball, and I've said, like, if your eyes is here, you probably would not be able to see the ball. Do you agree with this? So your eyes needs to be here. So the field of view is a similar type of concept. Like, let's say there is an object here, and there is a image placed, a plane mirror placed here. How will the rays be looking? It will be looking something like this. Okay. So Let's say you're standing here. Will you be able to look at this? Until and unless your X-ray machine would not be able to look what is the object. But the condition is different when you stand here. You will be able to clearly look. You can look. You can look. So the field of view is up to what extent the image is visible. That's called as field of view. So in this case, this is the field of view. Okay, that's all. Okay, so there can be questions asked from this also. Let's say a mirror is placed. Let's say a source S is placed, a light source, okay? And this is at the length L, and from length L there is a wall. To what maximum stretch? Okay, there is not a wall, there is a man. Okay, and the man is walking like this. Right, man is walking like this. To what maximum stretch the man climbs the image of the light source inside the mirror? So the man, to what extent the man can see the light source is the question. So it's as simple as it is, right? So simply draw a ray diagram, right? Do you agree with this? Yes, right? And this source will be here. So basically this is also a geometry question, right? So here draw, and this is the distance what we need to find, xy, right? This is L, and they have given the distance of the mirror, like the length of the mirror is D. So we need to calculate it. So can I tell this as D by 2? Fine. So D by 2 by this x is equal to L by 3L. Fine. L gets cancelled. D by 2x is equal to 2x by 3. Do you agree? Okay. 2x by 3, right? But we no need that x, so we need the value of x, not the d. So 3d, sorry, yeah, right? Sorry, yeah, right? Fine. So similarly do it for y also. D by 2 y, L by 3L, L gets cancelled, and y is equal to 3D by 2, and we need to add x plus y to get the field of view, right? So x plus y is equal to 3D by 2 plus 3D by 2, which is 3D. So the field of view, or the maximum extent up to which the man can see the light source, is 3D. Fine. Okay, I hope we are absolutely comfortable till now. Let's go further. Image formation by two plane mirrors. Let's go a bit in the second gear now, because this is an easy concept. We no need to waste a lot of time in this. Let's take up second gear. When mirrors are parallel, Okay, when mirrors are parallel, how many image will be formed? That's the question. Let's take two mirrors which are parallel, and let's say this is in distance A and this is in distance B. So the first image will be formed here. Do you agree? At the distance B. Okay, seeing this, there will be image formed here. Okay, here also the image will be formed at the distance A. Image 2 will be formed. Okay, seeing this, there will be image formed here, right? Image formed here. What will be the distance? It will be the total distance, which is B, B, A, A. It will be in a distance 2A plus B, right? 2A plus B. So you need to see the distance between the mirror and the image and the object, right? So mirror is here, object is here. So what is the distance between them? It's A plus B, 2A plus B, fine. So similarly, here also by seeing this, the image will be formed, which is A, B, B. In a distance, I4 will be formed, A plus 2B, right? Okay. So seeing this, there will be image formed here. Seeing this, there will be image formed there. So infinite image will be formed. Fine. Moving further. Fine. Let's take two mirror case at an angle theta. In this case, it's not parallel, it's not 90 degree, it's angle theta. So how will you find it? So basically, if an object is placed here, and let's put as alpha and beta are the angles between them. So there is a method called crisscross method. This is mirror 1, mirror 2, and the angle between the mirror 1 and the object is alpha. The angle between mirror 2 and the object is beta, and what we need to do is we need to add alpha plus beta. Add alpha plus beta to this, you will get alpha plus 2 beta, 2 alpha plus beta, alpha to alpha plus beta again, 3 alpha plus 2 beta, 2 alpha plus 3 beta. So these are real angles. The angles will be given. Assume this is 60, this is 30, this is 60. At some point, even if one crosses 180 or if it reaches 180, we should stop the process. And how many times this has happened, that will indicate the number of images. Let us see an example at the last. Just understand the process, that's more than enough for now. Moving further, when they are parallel, the mirrors are kept parallel, how many images will be formed? So this is object. So as you all know, at perpendicularly one image will be formed. Here one image will be formed, image 1, image 2, fine. So from here, by seeing this, if the mirror is extended, here image 3 will be formed due to image 2, and if the mirror is extended here, due to image 1, image 4 will be formed here. Both will overlap and will form the same image, fine. So basically I1, I2, I3 will be the image. So total number of images formed when the mirrors are perpendicular are 3, fine. Okay, moving further, as I said, I will give some examples so that you understand it better. Let's say there is 20, 30 degree. Okay, there is object placed, mirror 1, mirror 2, crisscross method, mirror 1, mirror 2, and this is given as 30, and this is given as 20. 30 plus 20, 60 plus 20, okay, 30 plus 40. What is 60 plus 20? Guys, this is 50, right? So 50 plus 20 what? 70. 30 plus 50, 80. 50, 120, 130, right? So still nothing has reached 180, so I can move further. 50, 180 reached, and 170, so reached. So count the number of values: 1, 2, 3, 4, 5, 6, 7. Don't take in account, don't take 180 or 180 above in account, just count the values: 1, 2, 3, 4, 5, 6, 7. Total number of images formed is 7. That's it. Fine. And there is also another exceptional cases. If it's 45, 45, and this is mirror 1, mirror 2, 45, 45, 90, 135, 135. Fine. Moving further, 90, 185, 165. Okay. So in this case, just see, this is 90 degree. As we all know, 90 degree, we have seen 3 images will be formed, but as you can see, 1, 2, 3, 4, 5, 6, right? 7, sorry, 6, right? So this is the case where, exceptional case, where this, in this one single row, if 135 plus 135 is equal to 360, this will be eliminated, this both will be eliminated, and we'll count only this 1, 2, 3, 4. But above 180 is also eliminated, so we'll count only 3, 1, 2, 3. That's it. So 3 images will be formed. Okay. Note, if theta is angle between the mirror, okay, if 360 by theta is even and we count it as n, okay, if 360 by theta is even and if we count it as n, then object placed symmetric, number of images will be formed as n minus 1. Okay. This is a shortcut method. Fine. So if 360 by theta is even, then object placed, and then object is placed symmetric, which means if there is 60, if it is 30-30 angle and the object is, and this is 30-30 angle, then the number of image will be formed is n minus 1. Similar to unsymmetric angles also, it's n minus 1. Okay. If 360 by theta is odd and we take it as n, okay, then the object placed symmetric, it's n minus 1, but unsymmetric, it's n. Unsymmetric, it's n. Just let me give an example. 60, 60, 360 minus 120, right, which is even, okay, even n, and it is symmetric, So n minus 1. So what is this? 3, right? So 3 minus 1, 2 images will be formed. Fine. So similarly 30 30, sorry 30, let's say a different example, 90 30. Fine. 90 plus 30 is 120, again even, right? So again we'll get 3. Okay, see this is odd, so we took in the category n minus 1, but this is also odd, 360 minus 120, but it's not symmetric, right? So we'll take n images are formed. Fine. Okay, let's shift our gear to gear 1. Fine. And go for a new concept which you have not be studied in any previous grades: velocity in plane mirror. I hope you have not studied. Fine. So when objects moves parallel to the mirror, okay, let's say this is x, this is the object. So how do you think the image will be moved? Similarly like this, right? Y, image will be moved like this, same, right? So x is equal to y. See, this is the position, x is position. Let's say object is here, x1 position, the image will be y1 position, but exactly parallel to this, right? So I can write it x is equal to y. So let's just differentiate it. Dx by dt is equal to dy by dt, which is velocity of object is equal to velocity of image in parallel case. Okay, when object moves perpendicular to the mirror. Fine. When object moves perpendicular to the mirror. Okay, so let's say this is the object, this is the image. The object is approaching the mirror, okay, and the image will also approach to the mirror. Fine. So let's say this is x, this is y. At the point x, it will be at the point y, right? As you can see, if this is x, this is minus y, right? So x is equal to minus y, because this velocity is the negative of this velocity. Hope you understand. So now if I differentiate, dx by dt is equal to minus dy by dt, right? Velocity of object with respect to mirror is equal to negative of velocity of image. Okay, velocity of image with respect to the mirror. Okay, so if this is like 3 meter per second towards the mirror, it will be minus 3 meter per second towards the mirror, not like that. So please understand, with respect to the mirror is velocity of object minus velocity of the mirror is equal to minus velocity of image minus velocity of mirror. Fine. Okay, this is the condition for perpendicular to the mirror. Fine. Let's solve some interesting questions. Example, let's say there is a mirror. Let's say this is an object moving 5 meter per second, and let's say the mirror is moving 2 meter per second. What will be the velocity of image and what will be the velocity of image with respect to mirror. Fine. So just see the case, it is perpendicular to the mirror. Okay, so as soon as you see perpendicular to the mirror, you need to write this formula, right? Velocity of object minus velocity of mirror. So what is velocity of object? It's 2 meter per second, right? Velocity of 5 meter per second. 5 meter per second. Take one direction as positive and other direction as negative. So I will write plus 2, right? 2 meter per second, which is minus velocity of image minus so velocity of image minus the velocity, wait a minute, plus velocity of mirror. Velocity of mirror, we know that is according, it's gonna be minus 2, right? Minus 2. Fine. So this will be 8 minus velocity of image minus 2, which will go on that side, and it will be 10. Velocity of image is equal to minus 10 meter per second. So from this directly I can say VIM is equal to 7, VI is equal to 9, right? This is 7, so this will be 9. Fine. Here there will be 9 meter per second. Fine. So moving further, let's solve a step up question. There is a mirror, there is an object, okay, it is moving like this in 2√2 meter per second. Okay, that is 45 degree, and this is object. Okay, the mirror is moving here and it is moving like 37 degrees, 5 meter per second. Fine. Well, okay, so velocity of image is equal to what, and we need to find the velocity of magnitude of image. Okay, these things we need to find. So from the given information, we know that this object is moving at 45 degrees from the x-axis at the speed of 2√2 meter per second. Don't worry, we need to use the same formula here. VOM is equal to minus of VIM. Fine. So think what we should do. So velocity of image, can I tell what's this? Cos theta, right? 2√2 cos 45. What is cos 45? 1 by √2. Okay, sin theta, same 2, right? So 2, right? So same thing, 2 meter per second, same 2 meter per second. But this is not required, right? This is not required. The only thing it is required is in this direction. right, in this direction. So can I tell this is gonna be 5 cos 37? What is 37? So what is cos 37? It's 4 by 5, right? So 5 will get cancelled and it will be 4 meter per second. Fine. We know that velocity of object minus velocity of mirror. Velocity of object minus velocity of mirror is equal to velocity of image minus velocity of plus velocity of mirror. So velocity of object is 2 meter per second. Velocity of mirror is 4 meter per second, which is minus 2 is equal to minus velocity of image plus velocity of mirror. What is velocity of mirror? 4, right? So it will come here and it will become minus 6 is equal to minus velocity. Minus gets cancelled. Velocity of image is equal to 6. Okay, magnitude is equal to 6. Okay, if you want in a vector form, it is 6 I cap. That's it. Fine. Let's go for another question. This is a good question, right? Let's say a ray goes here. Make this as homework. Okay, this is theta, this is theta, this is theta, this is theta. I think you can't solve this question. Okay, just leave it for now. Let's go for spherical mirrors. Okay, what are spherical mirrors? How it is obtained in the first place? So let's say there is a sphere. Okay, there was a sphere, and what these scientists did, they just cutted the sphere. They just cut the sphere into 2 parts. Okay, so one thing they silvered it here, and other they silvered it inside, and this became concave mirror, and this became convex mirror. Okay, it was great, and this was known as center of curvature. Okay, I hope you understand, right? So those type of terminologies are all there, but I think you would have studied in previous classes. I no need to teach it again, but yeah, the focal length, I will just teach some basic terms. Distance from the pole to focus is called focal length, right? Before seeing these focal length definitions and all, let's see first how these mirrors rays are formed. Let me take an example of a concave mirror and a convex mirror. I'm gonna shade it like this. I hope you can spot the difference. And I'm gonna put an incident ray like this. You can take any rays, right, from anywhere, no problem, but you must understand that where it will diverge, that's the main thing. Okay, if you incident a ray from infinity, it will diverge in focus. Okay, or divergent focus. Or in other words, I can say if there is a parallel ray according to the with the principal axis, it will diverge at the focus. Fine, focus. So similarly, if I draw here, it is a diverging ray. So sorry, it is a diverging lens. In that case, when we extend the reflected ray, I will go and end up somewhere here. That is also focus. Fine, clear? So can you spot the difference that here the focus is in this direction and focus in the convex is in other direction? We always take the direction of the object to the mirror as positive. For example, this is object, right? So this direction will be taken positive. So in that case, I'll take focus here as negative, focus here as positive. I hope you understand, right? So convex mirror will have positive focus and concave will have negative focus. You need to understand that. Right? So what is a focal length? Distance between from the pole, this is the pole, and the focus is called focal length. Okay, and we need to follow some sign conventions here. Okay? Be very cautious in this. Okay? Direction of incident ray is taken as positive. Rather than saying this complicated things like objects distance towards the mirror is always taken positive, I can also tell it in a simpler way that the incident ray's direction is always taken positive. The incident ray is here, positive, fine, and the distance above principal axis is taken positive. This is taken positive and this is taken negative. Okay, you must understand that incident ray direction is positive. Similarly, direction distance above principal axis is negative. Okay, fine. So in this chapter we will be learning mirrors, of course, but under some assumptions. What are those assumptions? Rays are paraxial. So what are paraxial? So it's the rays are literally near to the principal axis. That's what we mean by paraxial. Mirrors are small. Mirrors have small aperture. Fine. Mirrors have small aperture, which means it can take only small amount of light inside. Fine. These two assumptions only we are going to learn all these concepts, so that there won't be any crumbles and jumbles in this chapter. Fine. Moving further, we had a JEE advanced question some year, I don't remember the year, but there was a question asked, right? We say that F is equal to R by 2, right? So that isn't actually true. This is wrong. Due to this assumptions only we come to a conclusion that it is equal to R by 2. If these assumptions weren't there, it will be something like F is equal to R minus R by 2 sec theta. This is the general case. Fine. Just because they are paraxial rays. Let me draw this diagram to make it you understand this, it will be something like this, right? Fine. So if I take this as theta, so this is theta, okay? Just because they are paraxial rays, they are literally very close, which means theta is literally very very less. Then when sec theta, when theta is very less, we can assume that as 1. So this goes to 1, okay, which will ultimately give an answer that f is equal to r by 2. Fine. F is equal to r by 2. Okay, just because of those assumptions we get this answer. If you take off that assumptions, you won't be getting this answer. So with this we will complete this first part.